During the FIFA World Cup 2026, the stadium that will host the most matches has a retractable roof, so massive that it weighs as much as several Boeing 737 airplanes combined. Back in 2006, during its construction, the engineering team faced the challenge of building a 1,500-ton roof that could be opened and closed whenever needed, and that too on a structure that had neither walls nor pillars for support. At that time, it was the world's largest stadium, featuring the longest unsupported arches ever built. But the real problem was that the stadium's arches were curved at a 30-degree angle. On such an incline, not only opening the roof, but even sliding such an enormous weight seemed impossible. It was like trying to pull the weight of 20 Boeing airplanes uphill. Dozens of engineers were called in and every possible idea was tested, but all the experiments failed. In the end, the solution that worked had actually been invented 150 years earlier by a man who had absolutely nothing to do with engineering. Viewers, the stadium considered one of the biggest favorites for FIFA 2026 is the AT&T Stadium, located in the city of Arlington, Texas. Spread across 3 million square feet, this magnificent stadium has a seating capacity of 80,000 people at a time. Its interior volume is around 3 million cubic meters, so huge that the entire Great Pyramid of Giza could fit inside it, and there would still be room for thousands of spectators. Speaking of height, even if the Statue of Liberty were placed inside the stadium, it still wouldn't touch the roof. When you look at the stadium and examine its features, it's hard to believe how it was ever built. 2 arches stretching 400 meters without any pillars, a 1,500-ton retractable roof, centralized air conditioning, and 2 giant sliding glass doors as tall as a 12-story building. All these engineering challenges emerged in 2006 when the NFL needed a new stadium in Texas. The American football team Dallas Cowboys wanted a stadium that wouldn't be used for just 8 to 10 football matches a year, but could generate revenue throughout the entire year. Now, Texas is known for winter storms in the cold season and scorching heat in the summers, so making the stadium usable year-round meant it had to be an indoor stadium with climate control. Normally, when a roof is built over any structure, pillars are used for support, but if pillars were placed inside the stadium, they would block the audience's view of the game. This was the very first challenge faced by architect Brian Truby, who encountered some of the toughest challenges of his career during this project. He had to create a design for the stadium that had absolutely no interior pillars. But Brian's challenge wasn't limited to designing a pillar-free roof. That roof also had to support not only a 1,500-ton retractable roof, but also the world's heaviest LED screen hanging from it. The screen alone was calculated to weigh 600,000 kilograms. That meant the total load would reach 2,100 tons. The solution to this problem was hidden in a structure from history that most people have forgotten today. Back in 1875, engineers were laying a railway line in Portugal, but their work came to a halt at the banks of the Douro River. The river was 170 meters wide and up to 20 meters deep, and at that time the water flow there was extremely strong. This meant that bridge pillars could not be installed in the river. To solve this problem, French engineer Gustave Eiffel was called in. Eiffel designed a parabolic arch supported from the riverbanks, which required no pillars at all. At the time, such a massive arch seemed impossible, but Eiffel proved everyone wrong. This wasn't just an arch design carrying the bridge's weight. If you look closely, you'll notice small triangles built into it, and those triangles are the biggest secret behind the arch's strength. That's because a triangle is the only shape in the world that, no matter how much pressure is applied to it, may break, but will not change its shape. In engineering language, these triangular structures are called a truss system. And this same discovery by Gustav Eiffel was used in AT&T Stadium, but on a much larger scale. 2 arches, each 1,400 feet long, were built with a thickness of 14 feet and a depth of 30 feet. Their entire weight was transferred onto 4 concrete abutments placed 400 meters apart. Each abutment used enough concrete to build around 200 houses of 200 square yards each. And because these arches were made of steel, which expands in the intense heat of Texas and could even crack the concrete, expansion joints were installed between the steel and the abutments. These joints allowed the stadium to breathe. After 8 months, the roof structure was finally complete. A massive open-view stadium roof stood ready without any pillars. In the center, an iconic rectangular opening was left as a tribute to the old stadium of the Dallas Cowboys. But in AT&T Stadium, this opening had to be covered with a retractable roof capable of handling every kind of weather. However, nobody realized just how difficult this task would be. The retractable roof panels, whose combined weight was 10 times heavier than the world's largest animal, the blue whale, proved extremely challenging to open and close on those sloped arches. Obviously, when the roof opened, gravity had to be controlled, and lifting it upward meant fighting against gravity, like trying to raise 10 blue whales into the air. To solve this problem, the roof panels were first divided into 2 equal sections, so that when the roof opened, equal weight would remain balanced on both sides of the trusses. Now, if heavy-duty winches had been used to move them, then lifting a 1,500-ton structure would have required adding nearly 3,000 tons of winch weight on top of it. And if even one winch failed to open a panel at the same speed as the others, the balance of the truss would be disturbed, and that could turn into a disaster. Another major risk was that if a steel cable of a winch snapped by mistake, it could cause massive destruction. To solve this problem, the engineers turned to a 150-year-old invention whose creator wasn't even an engineer. In the 19th century, a businessman named Sylvester Marsh, who worked in meatpacking, was very fond of hiking. He often used to climb a mountain in Mount Washington. Climbing this mountain was not an easy task for ordinary people, which is why most tourists would return from the base itself. In 1869, Marsh designed a special railway track called a cog railway, also known as a rack railway. In this system, a rack is installed between the tracks, allowing the teeth of gears to lock into it. The track component is called the rack, while the gear attached to the train is called the pinion. Because of this system, the train could climb steep mountains without slipping backward. To prevent the train from rolling back downhill, a locking mechanism was installed above the pinion, allowing it to rotate in only one direction. If you've ever experienced a cog railway or a roller coaster, the continuous hammering sound you hear while climbing upward comes from this very locking mechanism. This brilliant invention became known as the rack and pinion system. For the retractable roof of AT&T Stadium, engineers decided to install the same rack and pinion system. The lines you can see on the stadium roof act as the rack or track, allowing the roof panels to move smoothly with a strong grip. To make this work, 130 motors of 7.5 horsepower each were installed. These motors power the pinions while closing the roof and act as brakes while opening it. And because the size of the gears is fixed, both roof panels open evenly, ensuring equal weight distribution on both sides of the truss. It takes 12 minutes for the retractable roof of AT&T Stadium to fully open. Keeping the entire stadium cool during the summer is no ordinary task either. The enclosed stadium has an internal volume of 3 million cubic meters, equivalent to around 75,000 standard-sized rooms. Cooling such a massive space is like air conditioning 3 Burj Khalifa-sized buildings from top to bottom. You may have heard of 1.5-ton, 2-ton, or at most 4-ton air conditioners, but this stadium uses an 11,000-ton chiller system. The air ducts alone are up to 6 feet wide. According to the laws of physics, cold air is heavier, so these ducts push cool air from above. The air flows over the audience and settles down onto the field. Meanwhile, the hot air, being lighter, rises and collects in the empty space above the field, where it is recycled again. To give the audience an incredible viewing experience, AT&T Stadium was equipped with what was then the world's largest LED screen. The screen weighs around 600,000 kilograms and contains more than 10 million LEDs. Suspended 50 meters above the pitch, this screen is as tall as a 10-story building. To provide visibility from every angle, the total surface area of the LED display is as large as a 3,000 square yard plot. No matter where you sit, this stadium's giant screen can be seen clearly from every corner. The stadium's glass doors are as tall as a 12-story building. These are not made in one single piece. Instead, they are built by joining many smaller panels together. Each panel weighs around 86,000 kilograms. These insulated glass doors also open and close using the same rack and pinion system. It takes nearly 18 minutes for these massive doors to fully open or close. Now let's come to the main area where the games will be played. At AT&T Stadium, turf was installed over concrete so that not only football but other sports and events could also be hosted by removing the turf when needed. However, for FIFA World Cup 2026, the stadium management is facing a new challenge. According to FIFA rules, soccer matches can only be played on real grass, not artificial turf. To meet FIFA standards, the Dallas Cowboys have set aside a budget of $300 million. But the question is, how can real grass be grown on a concrete floor? Since the stadium roof does not fully open, the grass cannot receive equal sunlight everywhere. To solve this problem, the stadium management has raised the field by 6 inches. A special drainage system has been installed underneath to remove water from the grass, and artificial UV lights have been added to maintain proper sunlight conditions. The management's plan is not to grow the grass inside the stadium. Instead, the grass will be grown on a farm in Colorado and then transported in refrigerated trucks shortly before the matches for installation. Along with this, the stadium's original seating capacity of 80,000 is also planned to be increased to 94,000. During the FIFA World Cup 2026, a total of 9 matches will be played at AT&T Stadium. The first match there will be held on June 14th, and the World Cup semi-final will also take place there on July 14th. After the tournament, the real grass will be removed and the artificial turf will be installed again.